This problem describes two solids of revolution that are created by rotating the given region about two different axes of rotation. Let us do these two volumes in parallel, and we begin with the sketch of the region in 2D. We will need an y-axis and an x-axis. The two curves that create the region both share the points 0, 0 and the point 1, 1. The first curve, the fourth root of x, looks something like this. While the second curve looks something like that. Let us indicate the region by shading it. Since we need to generate two solids of revolution, we will just copy this sketch. On the left side, we will indicate the axis y is equal to 1. While on the right side, we will need to indicate the axis y is equal to -1. It is always a good idea to also indicate the rotation. Next, we draw our general washer. So since we're rotating around y is equal to 1, it would create the smaller disk and the larger disk, like so. In our other region, our disks look slightly different. Here would be our small disk, and here would be our large disk. Let's remind ourselves of the general way to set up the volume of a solid of revolution using the washer method. So V for volume would be equal to the integral from A to B, that is the interval over which the washers would be running, of the washer's area integrated with respect to wherever the washers would be cutting through, and in our case this would be the x-axis, so we integrate with respect to x. So let's describe the washer area in the first scenario. We have that the volume is the integral from 0 to 1, because that's what our washers run from 0 to 1. And the washer area is created by the large disk, which has as a radius the distance 1 minus the function value of y is equal to x to the power of 4, minus the smaller disk, which has as a radius 1 minus the function value of the fourth root of x. And we integrate with respect to x. In the second scenario, the volume is also equal to the integral from 0 to 1. Again, these washers run from 0 to 1, but this time the area of our large disk is equal to the distance 1 plus the function value of y is equal to the fourth root of x minus the area of the smaller disk, which has as a radius the distance 1 plus the function value y is equal to x to the power of 4. And we integrate with respect to x. Now you have seen how to deal with the same region rotated about the different axes of rotation that is not the usual x-axis.